The last section for this chapter is the inverse functions section. The notes that we're going to do is just select the homework page from it. So starting off, there's a couple steps for inverse functions. These are not steps that are necessarily widely taught. They're just ways that I think it's easiest for you to remember how to solve these. Okay, the idea behind inverses is similar to the ideas behind inverse operations. So the addition operation is the opposite of the subtraction. And it makes sense. Like if you add 1 to a number, then subtract 1, you end up with your original number. Or when you multiply by a number and then divide by the number, you end up with your original number. Okay, lastly, we've thought about stuff like if you square x, but then take the square root of that, you end up with just x. Okay, so these are all examples of inverse operations. Okay, so then the question is, what would an inverse function look like? Well, if a function takes an x value and turns it into a y value, the inverse of that function would take that y value and change it right back to that x value. The way that we find these functions, though, sometimes it's sort of easy to think of, but usually it's a little more complicated. So I usually talk about, I think, 3 or 4 steps. So the first thing is, if your function starts off as a f of x function, change the f of x to y. Okay, your second step is going to be to switch x and y. Okay, this is really the idea of inverse. It switches all the x values and all the y values. So instead of x to y, it's y to x. Okay, and if you do a function and then the inverse, you end up with the original. So thirdly, you want to solve for y, and then at the end, rewrite it as the f inverse of x. Okay, so this -1, it kind of looks like an exponent notation, is the inverse notation. So it means this is the inverse function of f, whereas we started with the original f function, now this is the inverse function. Okay, so we'll follow each one of those steps. So first step for this one, make sure it's y equals, it is. Second step, rewrite it, switching the locations of x and y. So now it's 1/2 y plus 5. Okay, next, 1/2 y plus 5. Okay, now what we're going to be looking for is solving for y. Okay, so take that y value, isolate it. Okay, subtract 5 from both sides first. So we have x minus 5 equals 1/2 y. And then your last step is to multiply both sides completely by 2. On the right side, when you multiply 1/2 y times 2, the 1/2, the 2 cancels out. We just have y equals. On the left side, it's 2 times x, 2 times -5, so that's 2x minus 10. Okay, number 2, same idea. Switch x and y. So x equals 4y squared. So there's one thing that we missed on this last one. Rewrite it then using f inverse of x equals 2x minus 10. That's a little more precise. Okay, your next one though, switch x and y. Okay, so we have x equals 4y squared. And then what you want to do is solve for y. So you're going to divide both sides by 4. You'll have y squared equals x over 4. And then square root of both sides. When you take the square root, you need plus or minus. So we have y equals plus or minus the square root of x over 4. Okay, and then lastly, rewrite it as an inverse. The inverse f of x is plus or minus the square root of x over 4. Cool. Next, same idea. Switch x and y. So x equals 1/3 y squared minus 1. Okay, now, it's a little more complicated, just a few more steps ahead of time, algebra steps really. Add 1 to both sides. So x plus 1 equals 1/3 y squared. Okay, multiply both sides by 3. Make sure that gets distributed everywhere. So that's 3x plus 3 equals y squared. Okay, take the square root of both sides. You need a plus or minus, and now I'm going to switch the sides. Y equals plus or minus the square root of 3x plus 3, which means the inverse f of x equals plus or minus the square root of 3x plus 3. Cool. So 4, 5, and 6 work out very similarly. You're welcome to work them out on your own. But the main reason this comes up is we want to look at inverses of logarithmic functions. Okay, inverses of logarithmic functions and inverses of exponential functions. Okay, so looking at number 7, 8, 9. Switch x and y. Okay, so log of y minus 5. Now the tricky thing is we need to solve for this y that's in here. We have some experience doing this from other log functions where we're trying to solve for an x that's in there. Now we have variables on both sides, but really we're trying to isolate y. And so think of the base of a logarithm is 10 if it's not written there. So we're going to do 10 to the x power. And that's equal to anything that's in this parentheses, equals y minus 5. Okay, so we switched x and y, and then now we're solving for y. 10 to the x equals y minus 5. Okay, add 5 to both sides, so y equals 10 to the x plus 5. And then rewrite it as an inverse function. F of x, f inverse of x equals 10 to the x plus 5. Okay, so we can show that logarithmic and exponential functions are inverses of each other. For your next one, what we're going to do is do the same thing, switch x and y, and then exponentiate, and then solve for y. Okay, so starting off, it's y equals the natural log of 3y plus 2. So literally all we're doing is switching the location of x and y. At this point, it's technically the inverse function, but for sake of understanding, it's usually easier if we then go ahead and solve it for y, etc. Okay, exponentiate. Now the base of a natural log is e, similar to how the base of a common log was 10. The base of this next one is 2. So if it doesn't say and it's a log log, then it's 10. If it doesn't say and it's ln, then it's e. Okay, so next exponentiate e to the x, and that's equal to all this stuff, 3y plus 2. 3y plus 2 equals e to the x. Solve for y, so subtract 2 from both sides. We have 3y equals e to the x minus 2. Divide by 3, so we have e to the x minus 2 over 3. Okay, so rewrite f inverse of x equals e to the x minus 2 all over 3. You could also rewrite that as 1/3 e to the x minus 2/3 if you wanted to. Okay, last one, number 9. This is the last log inverse we'll do. Later we'll look at some exponential inverses. But switch x and y. So x equals log base 2 of 5y plus 2. Okay, exponentiate 2 to the x equals 5y plus 2. So 5y plus 2 equals 2 to the x. Now I'm saying it one way and kind of writing it on opposite sides. I know it's easier when we have the y values on the left side when we're solving for it, just something in our brains, or maybe it's how we've always practiced it. So that's why I keep writing the y on the left side. You're welcome to solve it either way. Okay, subtract 2 from both sides. We got 5y equals 2 to the x minus 2, and divide both sides by 5. So y equals 2 to the x over 5 minus 2 over 5. And then rewrite it as an inverse. F inverse of x equals the same thing. 2 to the x over 5 minus 2 over 5. Great, okay. So that is the log inverses. Okay, the exponential inverses. So if you think about it, the log inverses turned into exponential functions because we defined a logarithm as an exponential function. Going the other way now, it's going to define it. Exponential inverses are actually logarithms, and so you'll be kind of interested to see how that works out. Okay, so first step is going to be still switch the x and y values. So we have x equals 3 to the y value minus 5. Okay, so we need to get this y value that's up here in the exponent by itself. What we're going to do is get this by itself, then we're going to take a log, and that'll help us solve it out. Okay, so first step, add 5 to both sides. We're going to have x plus 5 equals 3 to the y. Now it's going to be easiest if we do a log with this base. Okay, so with a base of 3. Other ones would work as well. So what I want to do is do log base 3 of x plus 5 equals log base 3 of y. Let's change that. Log base 3 of 3 to the y. Okay, so this exponent can come down. So we have y equals log base 3 of x plus 5. And anytime you have something like this, log base 3 of 3, log base 2 of 2, that's just 1. So we have y equals log base 3 of x plus 5, and let's rewrite this in inverse notation. F inverse of x equals log base 3 of x plus 5. Okay, so definitely, I think this feels a little bit trickier. So let's look at 11, and we'll maybe finish up with that one. Okay, so in 11, this is what we're going to try to isolate. Because first step is to rewrite it. X equals 4, y minus 2, plus 3. Okay, next step, subtract 3. So we need to get this 4, y minus 2 by itself. So x minus 3 equals 4 to the y minus 2. Okay, now this is the base we want to use for our logarithm, base of 4. So we're going to do log base 4, x minus 3 equals log base 4 of 4 to the y minus 2. Remember, the reason we do that is this exponent can come down, and log base 4 of 4 is just 1, so it cancels out. So we have y minus 2 equals log base 4 of x minus 3. Well, last step, add 2 to both sides. So y equals log base 4, x minus 3, plus 2. Or, finally, the f inverse of x equals log base 4 of x minus 3, plus 2. Okay, so that's a general idea of how you can work these out. There's some homework that was assigned in class if you want to look ahead to that. The exponential test review, numbers 3, 4, 12, and 18. But this is the last section before the tests.